Hi everybody. Today I'm going to be giving you a quick run through on how to do a PSD analysis using Ansys Mechanical. So first in Ansys Workbench, we need to set up a modal analysis and a random vibration analysis. And what we need to do is we need to drag and drop from the solution block in modal to the setup block in random vibration. This will import the results of the modal into the setup for the random vibration analysis. In the right image, we can see that under the random vibration branch in the tree in the mechanical interface, the modal results are shown there as the initial condition for the random vibration. So as far as loads and supports go, in the modal analysis, we need to define some kind of support on our model. This can either be a fixed support, a displacement, or a remote displacement. For the random vibration analysis, we're going to be setting up some sort of PSD base excitation. And this is going to be scoped to the support that we defined in the modal analysis. So for that PSD curve and the random vibration, it's a piecewise linear frequency table. So as the user, what we do is we define a series of plots or a series of points of PSD over frequency. And then Ansys Mechanical just does a linear interpolation between those points to fill in the rest of the curve. Under analysis settings in modal analysis, we want to take whatever the highest frequency in our PSD curve is and multiply that by 1.5 and make that our maximum frequency in the range. So we want to go from 0, want the frequency range to go from 0 to 1.5 times the maximum frequency in our PSD curve. And then in random vibration, we want to set the number of modes to use, set that to all, and under exclude insignificant modes, set that to yes, and then define a mode significance level. What this does is it will exclude some of the modes from the modal solution that are below whatever the significance level is, which is also known as the participation factor. So any modes found in the modal analysis that are below this participation factor will not be solved for in the random vibration. So that's it for the setup. And then we go into, after we solve, we can look at the results. And since this is a statistical solution, you're not available to see all of the results. So you can see there's a lot of grayed out result objects here, but we can still look at the displacement, velocity, and acceleration directional components. We can look at the normal and shear stress and strains and the equivalent stress. So here I have a sample project that I've set up, and I've linked the engineering data, geometry, and model of a modal to a random vibration, as well as the solution, again, to setup. If we go into mechanical, under the analysis settings of modal, I've set max modes to find to 50. This number isn't very important, but you just need to make sure that it captures all of the modes within the frequency range you're interested in. And then limited search to range is yes, and I've set the range from 0 to 4,500 hertz. The reason being that my PSD curve goes up to 3,000 hertz. So again, this is 1.5 times that value. I have a fixed support just on this back face here. And then I solve the modal analysis. After you do that, we can look under random vibration analysis settings. Again, number of modes to use is all, exclude insignificant modes, yes, and I've set the mode significance level to 1e to the minus 4. For me, this will exclude a few of the modes that are having a very small impact on my analysis, so we don't need to worry about those in random vibration. The PSD curve I've chosen looks like this. Again, it's just a table of frequency versus the acceleration. For me is what I used. Again, you can see it goes up to 3,000 hertz. And then after solving that, I have a couple of plots here. So this is the directional deformation. So you can look at that as well as stresses and strains, as I mentioned. And you can also define a response PSD. So what I did is I set a coordinate system kind of in the center face of this block here. And what this shows is the PSD response at that exact point